Hello everyone, my name is Yousuke Katsuda from Uesugi Group. Today I'm going to talk about my research, peeking into the cell with a chemical tool. All of you encounter a situation in searching in everyday life. For example, this is my home, and here's my son. This baby Godzilla often makes a lot of mess, and my cell phone disappears almost every morning. A situation like this makes our morning more fulfilling and much busier before going out for work. How would you find your lost cell phone in the mess? If you have an extra cell phone, you can call to the lost cell phone and find the spot where the lost cell phone is buried. But if the lost cell phone is set in the silent mode, this strategy won't work at all, right? So sound is very important in searching for items. So you make a physical change to the items you are looking for and see the reaction caused by the change you make. That's the best approach to searching for items. Okay, let's go back to my research things. My research, I want to explore the unique nucleic acid structure named G-quadruplex from the cell in the mess like this. Maybe you feel this is a little bit difficult topic compared to the case of the lost cell phone. Right, you are right, very difficult. I just said that unique nucleic acid structures. What do you have the image about the nucleic acid structures? So this is the image of Watson and Crick. The knowledge they brought to the world of molecular biology was revolutionary. Their discovery is known as Watson-Crick base pairing rule. Adenine binds to thymine, and guanine binds to cytosine. Based on this rule, nucleic acid constructs double helix structures. You may think nucleic acid structure is double helix structures. In the case of DNA, you are almost right. Then double helix structures DNA information transcribed into messenger RNA, and based on the information of messenger RNA, ribosome, which is protein synthesizer, make a protein like this. This flow is known as fundamental principle of life. How about the structure of RNA? This is an image of RNA that high school students learn in science textbooks. This structure looks like string. Is this true? Recently, the study of RNA goes further, and it has discovered that RNA constructs many different kinds of structure like this, and one of a typical structure is G-quadruplex. If you put the structure in a more down-to-earth explain, this structure looks like ribbon. A recent study demonstrated that some RNA has this ribbon structure and interfere with the progression of ribosome, like this. And it has been said that if the number of this ribbon structure is large, the protein expression level gets lesser, and this can be cause of a serious illness such as cancer. How about the structure? What do I mean by G-quadruplex and ribbon structures? Here's once again Watson-Crick. They are known as pioneer scientists, but it is almost impossible for any great scientist to establish perfect and flawless rules. The G-quadruplex are constructed by the rule that Watson and Crick failed to identify. Let me once again remind you that guanine binds to cytosine by Watson-Crick base pairing rule. But this G-quadruplex does not follow this rule. Guanine binds to guanine under the presence of monocation ion, like sodium and potassium, and constructs like this planar structure named G-tetrad. And this planar structure can be coupled with adjacent planar structure by pi stacking. So an array with many guanine constructs like this structure named G-quadruplex. And G-quadruplex was known to exist in DNA. And as you know, DNA is very elongated molecules that have terminal ends. And these terminal ends have very unique sequences that does not exist in other areas of DNA. And this area called telomere. In this area, G-quadruplex prevents DNA from being decomposed by various enzymes, just like the ends of shoestrings being covered, so that the strings won't come apart. And also, G-quadruplex is known to regulate the length of cell death. And it has implied that a lot of G-quadruplex exist in cancer-related RNA, but exact location and function of this structure have remained unknown. If we are able to identify the position and clarify its relationship to cancer, do you think this structure will be an attractive target for anti-cancer drug? Imagine hundreds of people, a large number of people have died of cancer for hundreds of years, maybe thousands of years, I don't know. Yet, we have not been able to overcome this serious illness, even in the 21st century, because we haven't found any perfect anti-cancer drug. Even if we try to make a drug that targets for DNA, most of DNA has double helix structure, so which makes it difficult to succeed for a drug to succeed in binding to its target position. But G-quadruplex is very unusual but simple structure. So I believe that this structure can be an unmissable target for anti-cancer drug. It has been said that a lot of G-quadruplex exist in cancer-related RNA. The rules that Watson-Crick failed to identify might be of a new anti-cancer drug target. So I was determined to challenge myself with finding out of this G-quadruplex, where this G-quadruplex exists in cancer-related RNA. And this is our strategy. Just like the story of the lost cell phone. Important thing is to make a change for the very item you are looking for. And a ribosome make a certain amount of protein with or without any compounds like this. And this ribbon structure interfere with the progress of ribosome and reduce the amount of protein like this. And if we use a compound that make this ribbon structure harder, the amount of protein reduced because the progression of this ribosome become less aggressive. This analysis made us believe that it is possible to detect RNA G-quadruplex by detecting the change of this amount of protein. So to complete our strategy, first, we try to look for such compounds that have an RNA G-quadruplex structure by screening chemical library. Chemical library literally means a collection of wide variety of chemical compounds. Our laboratory has huge chemical libraries of 70,000 compounds. We evaluate these compounds one by one to look for the candidates that change the strength of RNA G-quadruplex structure. And then we succeeded in finding this compound named RGB1. When I examined it in various ways, we found that this compound binds only to RNA G-quadruplex structure. And using this advantage point, we evaluated it as a target of cancer RNA known to have this ribbon structure. And then I found that I was able to lower the protein expression level of RNA having this ribbon structure. And we are also able to discover new ribbon structure in the same cancer-related RNA. So this may mean that there are more ribbon structure in the cancer-related RNA than we know. And to further investigate these ribbon structures, we use the compounds to see if other cancer-related cell expression level will be affected. Now, we are not still sure about the function and location of this structure, but our goal is to use this compound to define the relationship and cancer and between cancer and RNA G-quadruplex structure. And I make a special study for chemical biology. Chemical biology refers to the use of the power of chemistry to solve the mystery of biology. Unfortunately, we cannot see directly into the cell inside, but we are able to peek into the cell using a chemical tool. What happened after that? It all depends on each researcher's individual interest. But in my case, I want to explore the unique nucleic acid structure using chemical tools. Okay? And hopefully, my finding eventually leads to the development of new drug candidate against the cancer. That's it. Thank you.